Hello and welcome back to another episode of Gifting Good Oxide. Welcome back, Sydney.
Hi, Sebastian.
And we are back with the path specs today. And you just pushed
Once again.
a few things. And in our prior conversation before recording, you already indicated there's lots to talk about. So maybe we do that. And
Yes. So, pathspec, what has happened? From looking at this, I feel like we're always pulling in like the previous to-dos basically.
yeah.
But that is a reason. And we can, yeah. So I'm because those are in the Git attributes crate themselves, and there are still some things that I need to figure out in the pathspec crate before I can fully take a look at that. So that's why this is still kind of, always being pulled with. But the rest is, it's looking a bit better on those fronts, basically.
All right. Then I copy this over. And yeah, we can go through it step by step. It's nice. It's like in a meeting where you had action items and you actually check the action items and see that they're done or that you update that. So, wow. So diligent we are. And let's see. So maybe this helps.
Yeah.
What is this about? Figuring out how to, which values to escape, right? That's the big one,
This
huh?
is the big one that I'm currently still working on. So that is not yet checked off, but the rest of them actually are now.
So the baseline script and parsing the result into global lookup table. Yeah, that's a cool one, I think. I always like to do that. So let's take a look. Okay.
So there should be a baseline function now, basically.
That looks familiar.
It does, right? I stole a lot of code. Yes, I admit it.
That's fair. Stealing from another crate within Git Oxide isn't technically stealing, even though honestly, it's something. If we copy this again and again, it's just the second time. We might want to put it into Git test tools, but let's just watch for it.
I basically just copied this just to kind of get a grip on what is actually happening, because I didn't fully understand at the beginning. So I just tried to copy your stuff over and then modify it for my needs. And now that it's working, I think we can take a look at can this be better. But yeah, at least the baseline for the baseline is there now.
Being fully biased on stuff, whenever I recognize my code, I of course assume it's perfect and I don't even look at it anymore. So it's great. But here's something changed. You have to look closely now. No, just kidding. No, it's okay.
That's I also put this just into, at the beginning when reading the code, I usually like, that's my white space.
I space it out a little. I was wondering, did I put this? Is this me?
Oh,
now it is. Now it is. All right. Anyway, I'm joking. So this parses, right. You guide me through it. I don't want to say anything.
Yeah, so basically it does the same as in your version. It just doesn't, it has like the hash map that it parses it into is a bit different. So I don't have, I think you had it like per repository and then per key. And I just have like one big file basically that it parses in. So one big hash map, and then it just sees if the command fails or if it doesn't, and then logs the exit code basically, and that's what it tests against.
Yeah, it's interesting because where's your baseline Git repository even?
There is no repository.
But yeah, are you relying on a parent Git Oxide repository being checked out by any chance?
So I wasn't really sure how this worked, but I thought I don't really need the entire repository for this. I just need this baseline Git file. So I just tried if it works, and it does, and I didn't question it.
Okay. No, I mean, I think this one here breaks test isolation because Git discovers Git repositories and it looks upward. And because we are in test fixtures, which is in our parent Git repository, this will actually run on the parent Git repository. And of course, within this, any code running within these files is usually assuming that it's sandboxed or in some private space, which it kind of is. But if you now, tell Git to edit stuff, it will happily change your parent Git repository that you currently work in. So this is why this is the minimal thing we would want here. And now this should still work because it doesn't need much, that command.
Okay.
And the test system now reinitialized everything and did the right thing. You just basically, you got an empty folder here. Like this script had no side effects whatsoever in terms of observable files. Oh no, wait, this file it creates, sorry. So this is a folder with this file only, but we really want it to be in a Git repository so that this ls files runs there. Then this is what surprised me, that I see this exact copy here, because this one here, it searches in subdirectories, yet you only have a single file. This makes this overly complicated, right? So as I said, I want to have one commit today. So this is going to be my commit. This is a very simple refactoring. Here we have our base, and we want to read the baseline, which is base plus baseline.git, and then all this deer walk stuff can go away. And
you can also get rid of in the cargo tunnel file, I think.
Yeah. Oh, I hate it when that happens. Where is it?
On a baseline Git, you're missing the closing.
Oh, right. It kind of indicated that as well by the, yeah, nice. Now it's working. Good point. Then let's remove the staff dependency walk deer. I don't know if I told you about that thought worker that I worked with who tended to never copy paste, but to always type to form a memory, and to, just rather learn how to be a fast typer and how to memorize than to how to copy paste stuff you possibly don't need or that then has other issues. And that might be a good explanation why, yes. Because ultimately, look, it doesn't take much, right? Like in your case.
Yeah.
And it's like, this is everything you wrote anyway. And like all the other stuff actually wasn't helpful to you, I think, because it was just convoluting what mattered.
Yeah, I think really what I was missing here is just this, take a look again at the refactor step, because the way that I arrived there was basically changing then a bunch of other things in the shell script and stuff like that. And because it was still working, I wasn't questioning this code. That's like the step that was missing that we're doing now, just taking another look and actually thinking, oh wait, what does this actually do?
I mean, you talked about it like it was a bit chaotic, your work session before. So I guess you either, postponed the refactoring or had it in mind, something like that. Of course, I think this kind of hastiness doesn't, this just makes everything take twice as long and is confusing and gives you a weird feeling. So I'd rather want to avoid that from happening generally, just as a, I don't know, something to watch out for, because this looks better to me. And it still runs. Okay, cool. Now, let's go back to the baseline script, because I really liked how many there are. That's cool. It looks pretty sleek, huh? I mean, nothing wrong with this. I mean, it looks easily maintainable. That's what I tried to say. It's nothing that I would feel is too wordy or too boilerplatey. It's just, here baseline, it doesn't even say record baseline, it just says baseline. So it's really kind of reduced to the minimum. And then this kind of thing. Yeah, it's interesting, huh? Like once it took me like way too many years to realize Bash is a programming language and you can actually have functions and stuff, and there's lots to watch out for. Don't do this, do this, and whatnot. But or here, just combine multiple things into one and have, it's.
Yeah, it took me a while to get this to where I wanted to be, because it's bit unintuitive sometimes, but
Yes.
thankful there was a template I could copy from.
Yeah, it definitely is not intuitive, but yeah, once you got the hang of it for the first time, you don't want to miss it anymore. And I really wonder when somebody comes along and rewrites or provides a bash replacement written in Rust with a nicer, better programming language that doesn't try to put traps in your way all the time, because this is a bit like programming C here. It's really not easy. It's easy to make mistakes, let's say. That's easy. And there should be better things, but yeah, until they are, I write my bash and I just work around the problems. So yeah.
Exactly.
And then we parse this, parse 2 lines, and that's it. Yeah, looks good to me. And the baseline map is simplified because it's just one map and not a mapping of mappings anymore.
And then this is being called by this one function basically that just checks checks the incoming pathspec, and then it also checks if it's missing from the baseline basically, which is really nice.
Yeah, this is always a bit upsetting here in Rust's hash maps, because here we have to allocate just to make a lookup in a map, right? I don't know, do we have to? Because oh no, wait, look here. Actually we don't, because K is borrow of Q. And the key, so let's see if I can put this to the test. Let's see. So that's a string. And can we say B string?
That's not imported, I think.
Oh, you mean we don't have it at all? Ah, we do have it. Okay, I just have to do it. Yeah, I actually don't know how to better write this. Let's just keep it very simple right now. So in theory, that should work. So that IntelliJ can't do it, that wouldn't bother me. It also had problems before, right? This always was highlighted here. No. Oh yeah, I should probably also use it. So see, that works. And this was me again saying, oh, there's this thing with Rust hash maps where some very old memory from when I was very young and didn't know better, or when it actually was an issue, I don't know. Anyway, when I thought this had to be like this, so if you have usually you have own keys, and then in order to look something up, you need an own version of that key, so you have to allocate just for the lookup, and that sucks. That kind of reduces the hash map performance right away, because you really can't, like these complex types. And this is why you can do what I just did. Because a borrow of a B string owned, that's a BSB stir.
Yeah.
And that's the, so that's the simple transformation here that doesn't cost us anything. And that's much better. And here we do that again, right? Here we do that again with the allocation. And I don't know, is this something you thought you had to do, or something the compiler pushed you to do?
With this, I think it must have been something the compiler pushed me to do. But also, I didn't really probably think about that aspect too much, like borrowed and non-borrowed. So yeah, probably more my fault.
Let's say in tests it probably doesn't matter so much, but this kind of code I can imagine you would be possibly writing in production code as well. This is why it's important, I think, to highlight, like whenever you have own things and you just have an intermediate object that has to be owned, then this is expensive, especially for a comparison, allocate, right? And this should not have to happen. So there is always some way around that, and we want to find that way. So let's look again. So we say B string here. So the exit code is not even parsed. And this is why we do the string stuff there. It's fair.
Yeah, exactly. Mm-hmm.
It's fair, but also I personally don't think this makes it any more readable. I wouldn't avoid parsing a number just to, you know, not parse it and then have to deal with this later. This feels wrong to me. So if there's any issue now with the comparison, which it isn't, by the way, it just compiles, okay, then the next step would be to actually make this a number. But you seemed a bit surprised that this just worked. And if you were...
I wonder why I did it in the first place.
Yes.
I'm not sure.
And I think you might, you know, maybe it's the stage in your Rust development where this tumor grows that is a little mini Rust compiler that tries to predict what the Rust compiler does, and the tumor is a bit cocky. So it says, I know how to do that. Obviously, that's this type, so I have to do that. It must match, makes sense, right? So I do this, and you just do it, and it works, and you move on. But actually, that's not the simplest way. And this is something I learned the hard way, for example. Do not try to anticipate the compiler too much. Write what's simple for you and what's intuitive, and that usually is just make it a string like this. And maybe it works because of these intrinsic these intrinsic implementations that you just don't know about that are there that make this work. And honestly, with comparisons, I'm always like, let's see. I don't know. I have no clue. Sometimes I have to do stuff to make it work. Sometimes I don't. These common things with strings, they're usually made so that they're comfortable for that exact reason. So yeah.
Okay. Good advice.
Then, so just going back to check. This is the status, and that's the spec. So we really do have spec is the status, and the status we can just make a U size. That's the spec, that's the status. U size, next unwrap. This unwrap is for something. And that's not a string. That's fair enough. Yeah. Well, I do have to. Okay, see? That's even fair to me. I have to do this, and that looks better. And it didn't take long to do that either. And this isn't even the end of it. True. Like when I write this, I really don't like it because all this unwrap, it always clutters you up. We are in a special situation here where we have to return a hash map. We can't really work with options or with results, but maybe there is a way. So first of all, the compiler is pretty smart in inferring the type. We can be explicit about this, but we also shouldn't have to be because of the baseline map, which is known, where the value is known. Compiler should infer that, and it does infer it. So now this line is a bit less tricky. And here for all these unwraps. So what about having some sort of closure that does actually return a result, and then we just unwrap this one, and then inside of the closure we can just do question mark like usual. So, and that we return. So that closure we will call it, and then we will unwrap. So I think this is more like it, and that will be the return value. And then inside of this, we go with no input, and then this, and this can maybe move inside.
The whole thing, okay.
And then we define that this is a create. Hey, do I have this? Create result. I don't have that yet. Create result, not yet. I usually put this. So this path spec is its own crate. Oh yeah, we didn't have any refactoring that. What? That's really the top level. What? That's the top level here, is it? So do we have some module? Some modules. Okay.
This is in the top level, yeah, true.
Yeah, okay. Okay, that's the next step, but let's start here on the top level then. We will use git test tools. I think it has that. So that's just a result type that allows you to get easy error handling, easy conversions by boxing everything so that you have a common type. And that is defaulted here so that, you know, you don't have to usually specify the value. Here we do want to specify it. We just say it's inferred. Let's see if that works with the inference. And let's hope that doesn't break other stuff, because now we don't have, we might use result output. No, we don't. Okay, cool. And in theory, we can now do this. And does it work? Fantastic. Sometimes I'm a bit surprised about these things. But now we can get rid of all of this stuff except for this doesn't unwrap. And we could even say something is wrong again, maybe? No, let's see. We expect 2 lines per baseline. Formatting doesn't work, so I'm a bit afraid that something is wrong. I don't know why formatting does not work. Okay. Or this line isn't actually so long, it just looks long on that big font size. Okay, if we call this maybe map, do I win anything? No.
Shorter.
Yeah, probably baseline map probably doesn't do much. I think the reason I called it baseline map in the original code is that it's literally a map of baselines. And then in there's different key value pairs again. But here, I think usually I just call it map as well because it's just, you know, easier. Okay, cool. And that's how you can work around the other problem. It maybe is a matter of taste, but I prefer this, I guess, so that I can get rid of these just 3 unwraps, huh?
Yeah.
But I didn't like that
That's
line.
nice.
So here is really, you know, it's a nice example. This is how you can do it. Here, I'd say either way probably goes, because that's not really that much better. There's lots of additional noise now, and you wonder why. So your call, roll back or keep.
No, I think we keep it. It's clear enough for me, at least. And
Okay.
yeah, it is a bit more concise in the actual logic, basically.
Just to show how I think I would have rolled it back. So I'm not entirely convinced this is better, but your call, so we keep it. And that's a commit, I think. That's already a bunch of valid refactorings here. What git config has changed? How come? Oh yeah, that was me just fiddling. Just a space that I added. Refactor. Yeah, that seems to be it. And we're done with this one. Okay. And now the next one. Here we have pathspec. It's strange, I never noticed that. But usually these tests, they should mirror a little bit the structure of the parent repository. So here we have parse, and it's literally testing the parse function.
Yeah, I think that was another thing that was just forgotten. Because at the beginning I planned like parse and match. So I thought, okay, I need like one base module basically. And then that just never happened. I'll just focus on the parsing for now. And yeah, it's just something that was never updated basically.
So now that there, it's getting more complex, I think, and the baseline is there, and I was wondering where this result should go. So this should always be in the top level, then everybody can use it, which means we just put everything else in here. And that should just work like that. What's the problem? What seems to be the problem in TeddyJ? Okay, you're just a bit slow. And what's the problem now in TeddyJ? Are you still just a bit slow, or is this real? Yeah. So these tests, they wanna, this is now in parse. Okay, so all these imports, they just don't go work. Okay, let's see if that still works now with the, okay, now this is a great result. And we're back in a working state, and now it looks more like parse fail succeed, parse fail, empty attribute specification, empty input. I just read it a little bit out loud so that I see if it rings, if it makes sense, succeed, attributes, and certain things. Okay, good enough. And I say good enough because I know later I might try to match it against the specification. And then I might try to map it more closely to the wording in the specification, but that's all. But for now, I think that's perfect.
Makes sense.
All right, that's another plain refactor. So that's also interesting that I say down to function level, so that you even have a module for a function that is under test, and then in there, in this case, you even have it substructured into fail and success, or fail and succeed or something. And that's usually rare, but also it makes sense if you have so many different inputs to kind of structure these inputs to the function a little bit, right? And you don't always do this, but in this case, it makes perfect sense, I think.
I mean, it's probably also because I'm really only testing this one function, and everything that's internal kind of is just tested with that. So maybe I could split it up differently to test the internal functions more. But then again, you do want the entire process tested anyway.
Yeah.
So
yeah, internal functions, you see that basically nearly never, unless these are very complicated and you have trouble finding input that will trigger that particular aspect of that internal thing.
Yeah.
In this case, I think probably not hard to find the input that you want, or to make the input that you need, as it's just one string away. And that means now this one here, this action item, just 30 minutes later on record, can be removed. But it's a big one, it's a nice one. Then try to parse mut and parse long, to parse long for less boilerplate.
Yeah, this was part of your refactor the last time. That's all basically implemented, yeah. So there's a function somewhere that now...
Yeah, mut pattern here, parse long keywords.
I didn't use destructuring here because it was actually nicer like this, because you still have to dereference everything. So the p dots was... I found it a bit nicer.
Yeah,
and
true.
The signature it's a lot shorter.
Yes. That's super nice to share from you, because you get auto dereferencing with that point, with
exactly,
that dot access, huh? And it's easily overlooked what Rust does for you here, and that already makes it worth it then to have an asterisk here all the time, right? So more or less. For matches, you don't need the asterisk, I think, potentially, because it auto derefs that or whatever. There were some rules that I always have trouble with, but a simple p dot we can handle.
I think so.
Okay, then this is also done. And the last one, use char instead of bstring.
Yeah, that was just for the specific error case. We really only checked the one character and I used the bstring, but now it's a char.
Yeah, okay, that was straightforward. I wonder what the found keyword. Yeah, here I'm a bit struggling with these, with found something, so to say, found, because it's so, you always find something, or you encountered, you could say encountered, or arrangers, or you could make up a nice attribute there that kind of always makes sense, but then you can also remove it, and it's never done. Yeah, and this is why I probably would just remove this found prefix, and I don't think anything is lost, and also do it here, not to forget. Short keyword, keyword,
What do they call it? It's like
key character, key prefix, key.
Short
keyword.
Short magic and long magic.
Yeah.
Keyword.
I mean, it's the short keyword, and it just happens to be one character, so I guess it's as good as it gets. Okay. That seemed to have worked. And the rest, on a quick glance, seems to be good. Okay, so now let's look at the mud again. So yeah, I think there's much. So we have this top level pattern that we are building, and it's reasonably defaulted. And from there we just parse things.
Exactly.
Short keywords, long keywords, yeah. So here, wait, I think here I found it interesting. How many fields do you actually access? Yeah, so here I think here I was thinking it's better to keep
only one. Oh, like the, yeah.
Because it implies that you use more than one to me. But you don't, so that makes it kind of overkill. So let's make this refactor for errors. Okay. And now this can go, but becomes p signature, right? Because this is how it was before, and I like that. I think there was nothing could go wrong with that. That makes sense. It's just what you have to do, right?
Yeah, true. It's clear that way, you're right, because you really see at a glance what's happening, actually.
And so we keep signature of magic signature empty, and it's a mud signature. And we keep assigning to that in a loop, and here return the magic signature. And that should work. Okay. And you'll see when you review your first PRs that it's always easier to see this when you're not writing the code.
Yeah.
But, so yeah.
That's true, I guess, with the mud going in, it's like, I'm not sure what happens there.
This means every time every time you start a new session, you're actually also reviewing your previous code, and you will hopefully find something to make it better, you know? Let the brain spin overnight and something happens, and then you see things you didn't see before. That is why I think also making many small sessions, I find that more valuable. Having these marathon sessions where I don't know, I become less effective over time. So
yeah, for sure.
Having these regular breaks and some time in between really makes sense for me. All right, now that's just another plain refactor, and we are done. Now for the big one. Yes,
Yeah, And maybe just as a quick warning, like I said, this is very much work in progress, and I think I haven't honestly also fully understood the problem, because I don't fully understand how Git attributes work and how Git pathspec basically comes into this. So yeah, this is still something I'm trying to figure out. But maybe what we can do now, without needing too much time, is just really quickly, maybe I can really quickly explain you the problem that I'm having, and maybe you can help me with it.
All right. Is it okay to do that on my screen? Do you want to direct me to?
Yeah, absolutely. Okay. There should be one place. It's basically in the parse file. And there's a function called parse attributes. Yeah, and it's basically from here is how I handle escape values, because the attribute parser that you have at the moment in the Git attributes crate handles, so in the Git pathspec perspective, handles the attribute keywords themselves correctly. But as soon as there is a value attached to it in the form of keyword equals a value, that's where pathspec needs to do something differently, or basically unescape the values. Yes. But I don't know what the values are before parsing the attributes. Yeah. Yes. I think that explains the problem already. So that means I need to have some sort of maybe even custom parsing, or maybe just break up the Git attributes parsing steps a little bit further instead of using that iterator. Yeah, that's what I'm confused about. Like, how do I tackle this? In what order does this need to happen? And yeah, that's where I was at. Okay, cool. Yeah, makes sense. I understand. So, initial thought about this, I wrote the Git attributes parser, also checking closely what Git does there. And Git really doesn't care about escapes and doesn't, or I think it doesn't, and it didn't have any functionality regarding that. This means that whatever pathspec in Git does, either it just re-implements the attribute parser, which Git sometimes does. They kind of re-implement stuff a lot and a bit different, and that's that. So maybe that's happening, and that tells you, yeah, maybe that's something you have to do too, because the attribute parser isn't ultra difficult either. It's not super complex, and some pieces you might be able to reuse from that crate anyway, regarding validation, for instance. I wouldn't want to have that duplicated, but that a bunch of lines of parsing, honestly, I also wouldn't mind if that is the need and would make it easier. But then the second thing I'm thinking here is that it's more like, what does Git do? Do they just re-implement the parsing, or do they just... They do. They do. At least to a certain degree, yeah. But that's where also a lot of the, like, this custom escaping and the custom error checking comes from, basically. I think it's around line 140. Yeah, add a value unescape. Yeah. And below that is a function that actually does the attribute parsing matching somewhat. Yeah. Yeah, I don't say I understand everything I'm seeing here now. Pathspec error match. That's also a matching here already. Ooh, interesting. That's the matching. So can it be that they don't actually unescape this until it's used? Or is it a problem for the, like, is it a problem for the current system to have these escaped values at all? Like in the attribute name, do you have to deal with escapes or not? No, it's like, or just the value. It's more so a problem for the baseline testing, because I know this is a value that's not allowed in Git, and so I should reproduce this. Whether it's done in the matching or in the parsing, I cannot tell, but that's what I'm testing against. Okay, and that already happens there. But ls files does try to match stuff, obviously, because it has the index and then matches the pathspec against the index. Hence, you will see these escape errors then, and this is why it happens. So here's already some,
wouldn't say it's too big, that decision, but a decision to be made. Do we have to be that lazy like Git and do it on matching? Does it make sense? Pathspecs will always be matched because that's why they exist. I think that's their value. So you have to pay eventually, and I don't mind to do that then. They might also be over optimizing here. Maybe they save allocations, maybe not. I don't know. But that's something I'm not concerned with either, because at parsing you can always see, oh, nothing was escaped, so use a cow or copy on write. It's a own copy only if there was something that had to be escaped. And that might also not work very well with the current parser. But maybe it does, because the parser, I don't know. But I see your problem. I see it more clearly now. Because then the data types change and everything kind of changes. And what you want, right, is to completely unescape something and give the whole thing to the current parser, and that will then refer to that piece that you provided even.
That would be ideal, yeah. But I can't just blindly unescape the entire string, because some parts need to stay and some parts need to be escaped. Yes. And I only know that after the parsing step. So I don't know, maybe I should just do like a very rudimentary parsing step. So I just find out what the keys and values are, or something like that. And then, I don't know, or yes, maybe that's too crossed and I just re-implement.
But look at this here. So here, for the matching each string list item, they seem to only parse that pathspec halfway anyway. And here they do some attribute parsing again, like undo or remove an attribute, or I don't know exactly what these are. Match unspecified, match unset. So this is exactly what's in front of a name of an attribute. And then find, and if there's none of these characters, then find the next equal sign, and then you can handle the value.
Exactly.
And they don't seem to deal with unescaping in the attribute name at all.
Exactly. It's not necessary. That part basically works.
Yes.
As it should.
So maybe that's for you then. I mean, that's already everything you might need to know. That you don't want to unescape stuff in the attribute name, because that might make it possible to pass in invalid attribute names, or I don't know, confuse the system. I wouldn't want that. You know how things are. It's always an attack vector if there's multiple layers of code that treat stuff differently, and I don't want to think about it. But so only escape the values is what I'm trying to say. And this for you would mean all you need to know is equal signs, I guess.
Equal is.
And then parse to the next barrier.
Yeah.
Or find the value.
I do like a I do like a mini parsing just for the value.
Yes.
And unescape that, and then I give that to the Git attribute parser.
Yeah, but then you would have to combine, because the attribute parser also wants kind of the attribute name equals then the value, so you would have to.
It needs the entire thing, yeah.
Kind of, you find an escape, okay, then you rebuild the whole thing, and
pretty much
have a cow instead. But if there's no, and this costs you, then you have to allocate, but only then. And the common case is probably there's no escapes, so that then you have a cow borrow, and that's just borrowing the exact slice of bytes that you already have, so that costs you nothing then. That's how I would then implement it. I would definitely do it on the parsing stage and not delay it to the matching stage, where you don't want to deal with that, I think.
Yeah, I mean, I still don't fully understand how they do the matching and parsing here anyway, because it's kind of all mixed together.
Yeah.
So this function is being called in another function called parse long magic. So somehow while parsing, they do matching. I don't know. That's all a bit different there, I think.
Yeah. Yeah, maybe they do it all in one. And don't really Yeah, that's exactly good. Git merges stuff together to get work done, and as valid as that is, and maybe it saves you a cycle even, I don't know. But it also doesn't make it easier to understand how that actually works, because you never have, makes it harder to test too, because now you always need some side effects. You're actually matching against stuff. So how do you test that? Oh, you need to build an index that can match, and then yeah, I don't know. I always think it's not worth it to do that, but also maybe we are just misinterpreting the names here, which might just be something very else. Because if it wants to match something, there should be something like, what does it match,
Matches
right?
against.
Yeah.
Yeah.
And I don't see that here either. And the item is a pathspec item, and that's more like something it builds up. But there's so much data here that seems it's related to matching, and it's just put together into one big structure. And I'd also think that these are not related. A pathspec is a pathspec, and it can match, and these are two different data sets that don't necessarily belong together. But Git also does that. It kind of puts stuff together that is algorithmically used together for comfort maybe, or convenience, or I don't know. So yeah, but I've never seen a reason to do that in Git Oxide, and always would avoid that, for now at least. Not knowing better, right? It is always possible that the Git people know why and it's the best, but it doesn't help readability and understanding. So let Git be 10 cycles faster than Git Oxide in that, I'm okay. So yeah, hopefully that helps. That would make sense to me.
That helps already, yeah. And because I'm still struggling with, I wasn't sure if I should because it feels a little bit like a hack, kind of just making it work for Git attributes. So if you say this is the way to go for now, I will definitely give it a try. But yeah, maybe it turns out that it's really easier to just rewrite it, or just kind of rebuild and take parts from Git attributes only.
Yeah.
I'll see.
Here's a, how do you call it? Train for thought. Food for thought. Train for thought. So yeah, food for thought. If you write an attribute parser that supports certain escapes, then you can basically look at the whole test suite of the Git attribute parser, or the Git attributes crate, and duplicate that plus escaping, because otherwise you don't know if you're actually parsing faithfully with all the nitty-gritty details, right? So that's, I guess, what always would make me want to reuse what's there and just put the other stuff on top, which seems to be like what Git is not doing. Git is rewriting the parser, but also I doubt they have the full test coverage, or maybe they do by now. Praise to them, because it's all running Git executable for each and everything, and it's a heavy test, let's say, for what it really wants to be. It's just string in something out. What we do, I think, is much easier and helps. So yeah, let's keep these benefits. Okay. So I would really, let's look at this with the specific escaping applied to only the pieces where you need it, and you just do the parsing as needed, because it's kind of trivial to do too. Judging by what Git does as well, it does it very simply. And if that really looks terrible, we can talk again and see if it makes sense. Yeah. One more thing, like having these nice chains of stuff. I mean, yeah, no, sorry. This is actually the chain that can stay. That's great. And I think this is how it will stay, because some potentially unescaped stuff goes in here. I was a bit confused about this for a moment.
Yeah.
And it's, yeah, look, I press undo and it jumps up there, even though I would expect it to stay with line 159 where I was. So this is confusing. If anybody sees this, would be nice if there would be a fix in Vim mode plugin, I suppose. So all that additional code has to happen here, and that should keep it clean, you know, that should be fine. Everything else was fine and should stay.
This will also move. This was just checking for invalid values basically, and if it encounters them, throw like return a result. But this will happen in the unescaping step 10.
Okay.
So yeah, this will all be before the parsing basically.
Oh.
Yeah, that was also something I was a little bit fighting with.
Yeah. I was wondering what's value. Why is this so complicated? Because it's a compact string. I think I'm going to change this to K string, which is the kind of same idea, that there is an own string that can own short strings up to, let's say, 20 characters or 23 characters. So without actually heap allocating, by the way. So that's the thing. And this makes these strings very small and efficient for what typical attributes are. And Git does it differently, but Git also can't easily just pull in a crate that implements this cool stuff for you, you know? So, but I'm happy to just say this is work in progress. Let's not look at it further. I think we are done here.
Exactly.
But before we are truly done, 51 minutes in this video, like this is something you should, you know, the little tumor in your brain should give you some mild seizures that make you revisit this and rethink your life and this. So it's like, especially since it's once again, I create an owned thing to get something else. I know fighting with types and you just want to make it work. And this is something you would otherwise not commit. It's nice you do that. Nonetheless, ideally you get around to not even do this ever. So strong that a version is, you know, for me it would be so strong. I would not commit this. If it's an intermediate, fine, but I would not commit this. Because then I might risk pushing it, and I don't want anybody to see this blunder. But this is valid feedback, by the way. I never really used this compact string, and it might be strange to use. I would hope there is an as string, and there seems to be. And this comes from compact string. So yeah, so you can do as string, so no need to toString and allocate there. And then, yeah, I mean, look at this. This already works. We don't have to leave it like this. Yeah, so this error is here. That's fine. So here we want to owned.
It's weird because I think I usually go for owned values, just because I know that every time, as soon as I touch borrowed values, it gets so much more complicated. And I know this is something that can be refactored later, but usually I just go for the owned version at the moment, at least, because I know I will struggle a lot more with the borrowed stuff.
Yes. Okay, fair. That's fair. And totally valid feedback. It's how do you call it? It's progression. Over time, this changes. By the way, I do the same, but only for field members. So I do not just borrow stuff in a structure because I think that's better. I don't. I just own things, and only if I have I know it's going to be a performance issue because it's somewhere deep in Git oxide and there are millions of that, then I'm considered to think about that much harder, let's say. Which doesn't mean I don't own, but I know I consider borrowing. Otherwise, I don't even. Yeah. But for functions, I never do. Like I start with the borrowed thing because I know that's going to be enough. And if I see that I actually want to own this thing because I want to mutate it around or whatever, then I will indicate that and say I want something that can be converted into and be B string.
I see.
And this is only, just for my own convenience. Like even if this is an internal function, I probably wouldn't do it because this is the thing that gets duplicated all the time. Now you have multiple inputs. Each time it gives you a new copy of the whole function. with a different input parameter type. And also that I don't really want usually, but if this is a public API for convenience, always there. This kind of thing. But internally, if I know I want a B string that I want to change, I take ownership of it. That's also fine, of course. But a borrowed owned thing, always wrong. Never. It's just like that. And this is why. And Clippy will also not like that. This is what Clippy will have told you about for sure. So now we can... Let's see. Does Clippy do that or...
Does not actually.
Clippy. Yeah. Okay, fine. Then it does not.
It should.
It definitely could, I think. Probably there's a good reason not to, because false negatives are rare with Clippy, by the way, really rare. And I think that's a measure of quality for Clippy. So I'm happy that I can, like 99.99%, I can trust Clippy. And otherwise you turn it off, right? If it's too annoying, like, oh, whenever I do anything in Python, I'm like, oh, really? Come on, just leave me alone. So, the Clippy warnings, yes, I mean, I also would have jumped on this one, but let's just see if there's anything that I find really important. Yes, this can be a single. Nope, that did not work. Okay, the mode has a problem. I'm unable to change these quotes to single quotes. This is what Clippy says. And that makes sense. Redundant pattern matching. And that's an interesting one, especially for a parser. It feels a bit like whenever there's something redundant.
Yeah, this is also a code that's not really working at the moment. I mean, it's not being used, so don't look at that too closely.
Okay, then we don't. And say, yeah, I'm not going to commit this. You can just handle Clippy another time. Oh, I should actually learn to unlearn. So in future, I'm not going to do this, but I'm going to do this. Oh. Ooh, interesting. Huh. That's interesting. Is everything still all right? I think so. Because at is equivalent to head. So it's just a shortcut to head. But this detaches. And this one doesn't. Interesting. That's surprising. Is it a feature or is it a bug? I wonder. I really do. And you know, I think, oh, now I get it. All right. I think I might have I don't know. I think I might have a bug in my refparse implementation, refspec parsing implementation, because for me, I implement this as equivalent to somebody says head, and head is the name of a symbolic reference, whereas at is interpreted here as whatever head points to. Hence, it's a commit name. It's like I type the hash. So look at the difference. Git checkout F, at resolves to this, so I detach.
Oh.
Yes. And it does not resolve to head. And for me, it resolves to head. And this is what I would want. And but I think it's not how Git does it. So there's already a difference in how Git Oxide implements it, even though when you use it, it's the same thing. But one ref spec knows about the name and you can use it accordingly. You can access the name then when if you implement a jigs checkout and you use the jigs or git oxide ref spec parsing, you would have, when somebody says add, you would have had as a name there, and this allows you to do what I would think the right thing. But with Git, you would only have the object name resolved, and then you have to detach. And that's super interesting. I should not forget that. But in any case, let's push this, because I think this review is totally done. Oh, what? I'm not fast forward. What? Huh. My push referenced at least one unknown git LFS object. Oh, right. Oh, man, that sucks.
Is that the baseline archive? Or
yes, it's that.
So because you forgot to pull it? No, I don't really understand this error.
Yeah, I made a new one by changing the respective file. And that is now added, was now added to Git. And I think what I can do is reset this one to the previous one from here, and then it should work. Okay, but that doesn't have to be in video, so thanks a lot for watching, and have a good day. Bye-bye.
Bye-bye.